Hi, and welcome to the Unreal Engine News and Community Spotlight. In case you missed it, Kine creator Gwen Frey visited us last November to discuss what the development process for her has been like as a solo developer working exclusively in blueprints. Jay and Gwen offered alternative perspectives on animation, working on large teams versus small. Be sure to watch the archive of her visit and follow her progress on Kine, which is a 3D puzzle game about music, machines, and dreams. We are thrilled to be sponsoring the 2019 Global Game Jam, the world's largest game jam event. Taking place January 25th through 27th, the Global Game Jam connects developers from all over the globe in a unique experience focused on building connections, creativity, and shared experiences. On last week's live stream, tech artist Tom Shannon shared general jam best practices and how to quickly add various multiplayer setups like split screen, LAN, and local multiplayer. Get signed up at a Global Game Jam site near you and check out our new Global Game Jam landing page for helpful resources to help you prepare for the jam. Famed Mad Max stuntman Guy Norris and his son Harrison created a tool using Unreal Engine to build upon typical previs practices to build something capable of handling fully interactive environments representing an entire sequence for their stunt visualization or stunt viz. Working in collaboration with the production team, they can place the camera anywhere in the scene, edit lighting on the fly, and try out various performances. While the original goal of StuntViz was to improve planning and execution of stunts, their entire crew was soon drawn to the instant feedback these interactive sessions offer. In effect, the Norse's StuntViz tool provides a living, breathing representation of the film that all creatives can use to iterate on different options. It is able to use all manner of input, including 3D models, topographical maps, accurate color palettes, and VFX like dust and volumetrics to create a precise digital rehearsal. Listen to our podcast with Guy and Harrison to hear how they use this innovative virtual production tool on their major feature film projects. On to our weekly karma earners. Mad props to these folks helping out their fellow UE4 devs on AnswerHub. So thank you to Evigme, Zoltan E, Shadow River, The Batch, Thompson N13, Nebula Games Inc., Chewer, Salih Balkan, Ben Vlodky, and Jackie. You all rock! Next up are wonderful community spotlights for this week. First on the list today is YAG, or Yet Another Gameboard. It's a shared RPG game board, your virtual table equipped with all the tools needed to play any game. Launch it alone to prepare a scene or a map, and save it for later, or with friends to start playing. YAG gives you dungeons, miniatures, dice, maps, and character sheets, but you and your friends have to bring the rules and the game. ArtExpoVR, a prototype for an interactive art exhibition, is our second spotlight this week. The project showcases the use of high-resolution photogrammetry for real-time applications. The exhibition was realized as a multi-platform experience and as both a VR and AR project. It's a really wonderful way to bring art from anywhere in the world into even your own living room. Our final spotlight this week is called Zombie Raid. It's a top-down action shooter with tactical and RPG elements focused on multiplayer PvP and cooperative game modes in development by a small team of 3 folks. Certainly one to keep an eye on, and the team hopes to have a demo available soon. Thanks for joining for our news and community spotlight. Hi, and welcome to our Unreal Engine livestream. I'm your host, Amanda Bott. With me, I have Tim Hobson, one of our wonderful technical writers, and fellow community manager, Tim Slager.
Hey everybody, how's it going?
So, welcome. Thank you all for joining us. Would you like to give them a brief overview of what we'll be talking about this week?
Yeah, sure. So I've seen, over the years, like a lot of people have always asked about like visibility and occlusion culling. So we're going to be talking a little bit about that. And we're going to be looking at really like 2 of the default methods that are enabled already in UE4 without you having to do any setup or anything. So essentially what that does is, just give you a high level for the stream, is it just essentially removes objects from the screen, from the final image. That way they don't have to be rendered, and saves you some performance along the way. So
it's always a very important topic.
yeah, optimization, you know, especially, you know, starting out, this is something you don't have to do. It's already there, and I'm just going to show you how you can really start to notice these things, use it for optimization, use some of the other things, and just be aware of what we have. And then maybe in future streams come back and we'll focus on some more refined areas of all this. But I want to give everyone like a high-level introduction, so that way you at least know what's going on, and then we'll get to some deeper topics later on. You know,
building the foundation.
Yeah,
so
yeah,
it can
exactly.
Expand
Does that mean this is going to be a multi-stream? We're going to see
I
you back?
think I've just
Yeah, I
volunteered
think you
for
kind
that.
of committed to that, yeah, so.
I volunteered, and then I will be voluntold. That's the way it works, right?
Sure.
Yeah.
Yeah.
Voluntold is like my
Yeah,
word for 2019.
It's voluntold. Anything you can do, you're
So,
voluntold to do.
yes.
So.
But I don't object. I like it, so especially if I know the area.
All
so,
right.
So yeah, I think I've got a couple of slides we'll kind of run through initially, and you know, I'll just kind of use that as like a foundation for explaining what these things are, and then we'll kind of like jump into an example scenes that I've got set up, and we'll kind of break things apart.
All right. Perfect.
Great.
Okay.
I can't wait to see.
Oh, it's gonna be one of those streams. Huh?
It is, absolutely.
All right. Okay, so if you want to go to the screen for me.
Yeah.
Oh, whoops. Okay, so what exactly is visibility and occlusion culling? This is you know, my little intro there. But you know, for games and real-time projects, what this is all we're really looking to do is reduce the number of objects that we actually have in the final image for the screen that we're rendering out. There's always a lot of things that are off-screen that just add up to the draw calls, the objects, the triangles, anything that's in the engine. It's like, you know, just because it's off-screen doesn't necessarily mean that it doesn't exist. And, you know, these culling methods grab all those objects and remove the ones that we don't really care about to make that final image. So UE4, it provides several different culling methods that we have just out the gate. So it's like we have some that are for distance, you know, there's a couple there. We have the ViewFrustum, which is essentially like the camera's field of view. We have some precomputed visibility options that are ones that are done offline, and then you can use them for mobile devices and things like that. And then we have a multitude of dynamic occlusion query options, which rely more on the CPU or the GPU, just depending on the device that you're on. And then lastly, you know, people don't always realize, but, you know, these, you know, you're developing your scene and everything, but optimization is like a really important thing, and UE4 does a lot of that stuff just out of the gate for you with these two default ones we're going to focus on today. So again, you know, we're only caring about what's makes up the final image that we're focused on, and we're wanting to spread that work across the CPU and GPU, because if the GPU is just focused on like all of the actors that we're doing occlusion for and culling of, you know, it just creates a bottleneck there. So throughout this, you know, it's like when we get into the example project, I'll show you how you can check those things and see where you are bottleneck, whether it's the CPU or the GPU. So again, you know, we have these four main areas of visibility and occlusion culling that we're going to focus on, and in order of cost effectiveness, we have distance. So distance, what that does is it culls any objects, you know, based on their distance from the camera, and you can do this on a per object basis or with a volume that actually takes the size of the object, and you can set some distance values. So it's grabbing anything within that volume and just anything within that size range as well. So and then the ViewFrustum, that's the one that's it culls objects that are outside of the camera view. So anything outside of that view we just don't care about, and we just go ahead and not render it. Precomputed visibility, again, this one's just going to call objects in an offline fashion, so we'll generate those during like a lighting build. And then the dynamic occlusion, what we're doing is we're relying more on the GPU and the CPU depending on the query method that we have there. But we're doing that in a fashion that's to determine it again, and just any object that is blocked by another that's within the camera view, we're using those queries to remove it from the scene. So let's look real quick at each one individually and just kind of break down some more things for us. So this one's the distance culling, and what I've got here in this little GIF is a per actor one. So do you look at me like that? Tim's looking at me wrong just because I said GIF instead of GIF. I love it.
You're making things up, man.
I'll make it. Oh, talk Chris Babcock, sir. Anyways, so in this one, this is a per actor one, and what I've done is I've set up like a very short distance for it to actually, you know, disappear within a certain range of the camera, and to not be rendered from a certain distance as well. So We actually use that in Fortnite quite a bit for lights, and we use it for a lot of other actors. Not on everything, because then you don't want all your objects disappearing, but smaller things that are at a distance you don't necessarily care about or can't see that detail of. It's really beneficial to go ahead and just remove those from the scene. And again, this one uses CPU to reduce the object, so you're not bogging your GPU down later on in the process, and you're kind of spreading things out there. And this one's ideal for like static geometry and can be used across any kind of project type, whatever, whether it's mobile, VR, desktop platforms, and all that.
You need to be considerate of how many things you call, though.
Right.
So, because you don't want a ton of things popping
Right.
in and causing those queries to happen.
Right. So, and I'll get into that a little bit more when I get into dynamic occlusion. But it's yeah, you want to spread things across like I'll come back to that.
Okay.
Okay. So with this one, this is the ViewFrustum I was talking about, and this is an image I jacked from the documentation I've written on it. So essentially, what we have here is the camera. We care about the near clip plane, which is how close you can get to objects before or where they start rendering at. So you can kind of see like the little image in here is our final image that we make up for the scene. Then we have the camera field of view, or the camera frustum, and that's everything that's in our scene. And then we have the far clip plane, which we actually use scene depth for, so that way we can see off into very far distances, like usually I think in like Max and Maya, it's like you can set like a clip plane, and then anything beyond that range you just don't really care about, and it's just not going to render or show up in your viewport, and we just use the scene depth for that. So, and then this is a really interesting
Horizon, right?
yeah, Horizon Zero Dawn. I remember this one making the rounds, and I really just thought it's like we don't have like this view type in
Right.
UE4, but it's it really just kind of shows what the ViewFrustum is doing. So as they're moving around, they're showing how it's just removing some of those objects and anything outside of it. Like you'll notice there's always like a little bit of a barrier, but it just depends
Right.
on the size of those and whether any of that actually interacts with is captured within the ViewFrustum.
Yeah, I remember when this came out. It was really interesting. A lot of people were interested.
A lot of people jumped on it and were just like,
Yeah.
"Wow, that's amazing!" And I'm like, "That's been around for a long time."
Yeah, it's just
So
it's
just, but no one's seen it visually.
nobody's actually like shown, hey, this is what's
Right.
actually happening.
Yeah,
You think the world always exists and is always there.
Yeah, I thought about like capturing like some frames like turning and just kind of showing the world, but I was like, I don't want to give anyone the indication that it's actually there, and I just have to make it up.
Yeah. that's fair.
But it's yeah, it's a really kind of cool thing that made
Yeah.
the rounds. I figured everyone would recognize it, or at least a lot of people would. So again, we only care about what's in the camera frustum, and things outside of it, we're not going to care about it as much. So that way, we're just removing them. That way, we don't have to consider them for GPU occlusion queries and things like that. And again, we're using scene depth here, so further on out. And then you can enable, and I'll show this too, but you can enable the camera view frustum, or camera frustum view through the show advanced and camera frustum. And then, all right, so precomputed visibility. This is another one. We tend to use this one more for mobile projects, but it can be used for medium and small size levels, ideally. But what you're getting is you place some volumes around, and you typically place these in your playable areas for your characters, and all these little cells, like whenever you do a lighting build, during that process, what it's doing is it's, for each one of those cells, it's storing the data from that cell of what actors are visible from that point. So as long as the camera is within it, you're setting up essentially an offline version of dynamic occlusion for your project, and it works really ideally for certain style projects, like where the player jump height, it's not going to get out of the cell, because like once you're out of the cell height area, which you can edit, you lose that ability to cull those objects, because it's only when you're within that volume in that cell. But it's a really nifty kind of thing, and the cost of it really scales with the level. That's why we kind of say smaller and medium-sized levels. It's just because the more data you have, it's getting stored, and then that has to get read back, and it just kind of can scale there. So, all right. So the biggest one we got is dynamic occlusion queries. These are the most expensive to use generally. I say generally just because hardware occlusion queries is the ones we've used, and that's your GPU. There's some other methods on here like software occlusion queries, which relies more on the CPU. So with hardware occlusion queries, we're using the GPU to actually test objects within the ViewFrustum. So anything that's within that view that is blocked by another actor, and again, I have a scene that's going to demonstrate this a little bit better. anything that's blocked by another actor is occluded, and that needs to be checked. Like all the actors within the ViewFrustum are checked against the GPU, and this is where the bottleneck can happen. Since we have a scene depth that determines these very long view distance, if you have a lot of objects that are getting tested against the GPU, you're automatically going to be potentially bottlenecked there because all those things are getting checked,
Right.
and it has to know whether it's occluded or not. So, so software occlusion queries. This is a newer one that we added in 420, and we actually used it to ship Fortnite on mobile. And what it is a CPU-based, and here I'll real quickly pull this over. We actually have a whole dedicated page that kind of shows you how to get it set up. This one is CPU-based, and what it is you have this, let me see if I can open this, because I know it's a bigger image. So what it's doing is it's looking at the buffer here, and what we do is we mark different level of detail meshes that we want to use, and then those are what are used as occluders in your scene. So if we scroll over to this side, this is the back side of the house, and we've set those front meshes up to actually be the occluders. So as when we freeze rendering, and we can actually allow us to move the camera around while keeping that same original view that we had, where everything was just kind of rendered for our final image. If we move around the back of the house, you can see that things are no longer being rendered because they've been culled. So that's a really nifty one. It's a really good addition to UE4 to give developers options on mobile. And the cost on that really does scale based on the number of LED meshes and occluders that you are setting up. So it's one of those things like where you can actually kind of curtail where needed and only use the size objects that you want. Another new addition that we had was round robin occlusion queries for VR, and what this does is it just alternates between one eye for occlusion queries instead of both. Before we were checking both eyes, and while it gives more accurate results, you're having to do occlusion queries twice, and you're essentially paying almost double the cost maybe. So what you do is, by enabling this, which can be done at runtime to check, we're actually saving more performance by only just worrying about one eye. But the problem there is, like, you can potentially have artifacts because you're only checking one eye at a time. So it's like, out of your periphery, you may see something just kind of pop in or it may pop out or something. But, it's kind of up to you to, determine whether that works for you or not. But it's a really good cost savings performance thing. Okay, so let me pause this for a second. Let me go to my project. And then we'll come back to some performance stuff.
Ooh.
Ooh, okay. All right. Okay, so I've got a scene similar to what I set up in the docs to kind of give things. I've just actually colored the meshes a little bit better. And what I've got from a top-down view is, if we look, actually, I'll tell you what, let me do this first. Let's go ahead and enable our camera frustum. So we're going to go to show. I think it was under advanced. Yes, advanced. And then up here for camera frustum. And what it allows me to see is the frustum for the camera and that view that we're getting. So I know on your screens it may be a little harder to see, but it's a little purple line that's running out, and it's kind of showing that volume for what we're capturing on screen. And with my camera highlighted, we can actually see what our final image is. And you'll notice that inside of that, even though it's smaller, you don't see any of the red or the blue. And what I've done here is just bombarded the scene with all these different objects to kind of show us, like, okay, that's the final image, that's what we care about, but we actually have all this other stuff that we don't care about. And we just want to make sure that's not rendered because we don't want to pay the performance cost on it. So initially, we don't care about the red immediately because all those objects are outside of our camera frustum. So those are going to be frustum view culled, or ViewFrustum culling, to just go ahead and get rid of those altogether. It just freeze up on me. Oh, there we go. So I have those as a group, and I think it just froze for a second while I was highlighting them and getting them rid of them. So I just hit them for a second just to show you. And then we've got all these other ones too that are all these blue ones are occluded by other objects. So again, if we highlight our camera, those are objects that we never see. So it's like, why do we need to really pay the performance cost of those? So it's like, this is where the GPU comes in with dynamic occlusion automatically, and it goes ahead and it checks all the objects within the ViewFrustum, off into the far, far distance, and just goes, okay, I don't care about all these, and I don't have my, oh, that's world settings. Sorry, 1 second. Like there's 113 actors right there that are selected, that are, or 42 that are selected, that we just don't really care about. So, what I'm gonna do is I'm gonna unhide all my stuff again, and then I'm gonna show you a couple tricks. So I'm gonna go to my camera that I've got set up. I've gone to actually possess that camera. Try not to move it so that way I don't, because it's always easy to move. I'm gonna freeze rendering on this, and what this allows me to do, and it's like I talked about a little bit earlier, is I'm gonna eject from my camera so I don't move it really. And so when I freeze the rendering, what I've done is frozen the rendering state from that camera perspective, and while shadows are still there, all the rendered meshes we don't care about have gone away.
Right.
So everything outside the ViewFrustum we don't care about. Anything that's occluded by another object we don't care about. So, and then if I just unfreeze, everything pops back in because from this perspective we see it. So let's see here. The next thing is, actually, let's go ahead and talk about the performance stats.
So they were actually asking,
Okay, yeah.
which one is the pure default? Is that the...
Okay, so the two default ones are the ones that this stream was titled by. So
Okay.
ViewFrustum is automatically on. You can't disable that one. That one's just always on. That one's even on for mobile.
Okay.
That one's always been on for mobile, and it's just anything outside the ViewFrustum we don't care about. This is where culling methods have always gotten a little confusing for a lot of people, and it's like, you know, maybe I wasn't making it a little clearer, but glad you asked questions. This is why I titled the thread like visibility and occlusion culling, is because occlusion culling we're caring about what's inside of the ViewFrustum to remove those objects, and that's more GPU based typically. Whereas anything outside the visibility part, outside the ViewFrustum, and then like distance culling stuff are going to be more visibility kind of things.
Gotcha.
So because we're going ahead and just removing those, and does that answer your question? I guess?
Yeah,
Okay.
I think so.
You think so? Okay.
We'll get another question if not.
Yeah, definitely. Okay, so let me look at the performance stuff here real quick. And okay, so I blew up an image here, and I've highlighted a couple of areas that we're going to care about. So the way you bring this up is if you type it in stat init views, and I'll do this in the scene in a second. Stat init views, what we get is we get some cycle counters, which show where time is actually being spent and how many milliseconds time is being spent on it. And then we have some counters which actually add up the different objects in the scene. So you'll notice down here, like, well, let's look at the top here. So like view visibility, occlusion cull, and frustum cull are the three that I highlighted. There's another one down here for like decompressed occlusion, but that one's for precomputed visibility, and I'll cover that in another stream one day. And but what we can see is we can actually see the time that's spent from whatever view that I had at the time taking this shot. You know, it's like, you know, we got 0.12 milliseconds on view visibility. Occlusion culling is, you know, like 0.18 seconds or 8 milliseconds. You know, and then down here in the counters at the bottom, what we're doing is, again, we're adding up all these all the primitives in the scene. So depending on how you're viewing your scene, whether it's possessing the camera, actually using it in a game view. If you're just working in the editor, you have to take into account that there's probably going to be some additional, or there will be some additional counting there for like the skylight or the directional light, because they actually are an actor in the world, excuse me, that has an object with it, like a mesh, that needs to be counted. So the thing to focus on here, since we're talking about this, is the frustum cull primitives. So we can see from this view that I took, and I'm fairly certain I probably took it from a good one, but we can open the editor in a second and look at it. It's like, there's, I don't remember where I take some of these screenshots. So it's like, I always like looking, I'm like, oh, what's the scene? But in this particular one, it's like just the ViewFrustum had already like called out 40 objects that from the camera's perspective that we don't care about. And then the occluded ones is looking at the ones that are actually just all the occlusion blocked by other objects within that ViewFrustum. Okay. And then let's pop back over here. And open up stat init views. Some of these I already typed out earlier, so from this one, I'm going to go ahead and possess my camera. I'm going to go back up here to perspective, and then I've got my cinematic actor camera here. I'm going to hit the little pilot button, so it gives me the actual view. And I do apologize because this is a little smaller on the screen from where I'm sitting. But what we can see is we can get an idea of where our time is being spent. And we'll look at a practical scene. I've got one with Soul Cave. That's actually like a developed scene, not just like my little spheres and walls and cubes. And then down here is, again, we have the, I did take it actually from the shot I was thinking I did. Because we got the Frustum call, there's like 40 objects outside that we just don't care about, all those red ones. And then the blue ones are being occluded, colored. Then, all right, so let me open up Soul Cave, and then we can actually look at this again from a more practical scene. Okay, so out the gate here, we can see that this is more representative of like a real scene that someone would have. It's like we've got 1,760 some odd objects right here within our view.
Right.
If I actually click the camera and move, and if I hit G for game, you can actually see, I think that it went down a little bit. I can't quite make it out.
The number of primitives stayed the same. Oh, no, it didn't.
You can look behind you too if it's a little closer.
Oh, that's going to
goes
tear my
up.
neck up.
So it goes from 1761 to like 1790.
Oh, okay, yeah. Not too much, but in general,
But the idea is that it's
the idea is yeah, it's there. But you can actually see, so going back to the cycle counters here and how much time we're actually spending on occlusion, you can actually see that we're actually spending more time here on the objects within our view and getting a higher millisecond count because we are using the GPU for a little bit more. So if we focus down here on the process primitives, one thing you can notice too is as I shift my view and move around, we can see that the custom Frustum cold primitives here and the occluded primitives are shifting around within that number that is counted up for the entire scene. That was the number I was thinking of. Not the top one is everything that's there in front of you. So
it's everything.
there we go. But yeah, as I shift that around, it's like I can get an idea. So one thing I'm going to do real quick is I'm going to disable that, and I'm going to go to this other option that we have, but I actually got a pi for that.
Wait, we're having pi?
Yeah, we're going to have pi. It's in preparation for like Pi Day.
Oh,
We
okay.
got to build up to that.
It's
right?
coming.
Yeah, I know.
Yeah.
Can't wait.
We're baking the pie?
Okay, so I've gone into Pi here, or Play in Editor, and I'm going to use this command called toggle, actually. There we go. Toggle debug camera, and you can only access this during Pi. But what this gives you is it gives you a couple of hotkeys and things you can use. It also, like for instance, like freeze render, it allows me to do that really quickly just by hitting F. So that way, again, it's just freezing everything really quickly. And oh yeah, I forgot I'm not in the editor, so I can't use that command. Just makes it look all weird and around. But you can see it's like with the freeze render, we're doing the same thing we were before, where it's freezing that viewpoint, and then our default actor is right, the little editor sphere. I can adjust the field of view by using the common commands. So I recommend this camera just because, like, if you have your scene and you're wanting to try to debug some areas and just kind of get an idea of things, you can actually use this to move around the world. It actually does have some hit test stuff there, so that way it's like if anything is not rendered when you've frozen the rendering, it actually will still hit that object and show that the world, you know, we're removing it from being rendered, but we're not drawing it, but it is still in the world.
It's still, cost is there.
Yeah, just right to some degree. But let's see here. And then let me go back to stat init views. Oh, helps if I type it right.
No, it doesn't.
No, it doesn't. Okay. So again, you know, it's like as we move around the scene, we can start to see these things. And I do recommend like a scene like this because this is like really decked out, and you can kind of get an idea of if you're kind of curious about these things and want to optimize your different levels yourself. You know, these kind of things do help you to see where your time is being spent. And this is where like some of those other occlusion methods come in that aren't going to necessarily be covered in the stream, but like the distance culling, when you can actually, you know, for larger objects, if you don't care about them, or cold distance volumes, you can use those to get some of the smaller objects. Like there's maybe some rocks and stuff that are really small from far away you don't really care about, but you know, as you get closer, you want those to kind of be visible and show up.
Right.
So then here, and then the last scene I'm going to show here is I've got another like little demo scene. Are there any questions or anything so far?
We've had a few coming up.
Okay. I mean, if we want to take a little break between these and answer those, I can probably try.
Sure. So I think in reference to your first scene with the gray
spheres,
shapes and
yeah,
the
yeah.
stuff, they're asking if those shadows are absolutely baked in. So are you going to see
Those were not baked in. So I did everything dynamic just because I didn't want to have like bake the scene out and then have to explain. It's like, okay, you know, we got like some blocky shadows because I didn't crank up the light map resolution. But no, so whenever the rendering is frozen, you can actually there's a couple of key console variables you can type in, like for occlusion and freeze, and they'll bring up different things. You can freeze like different particle systems, foliage, clustering. I'm only kind of focusing on just like freeze rendering, which is like a general one that covers like static meshes and skeletal meshes and stuff. But it just freezes the rendering state. It doesn't freeze, and it freezes the shadow state. So it's like if the object isn't rendered. So for instance, like I was trying not to get into lighting stuff in this stream, but there's so for instance, if there's like a really tall pillar off screen that's casting a really long shadow, the object itself, the mesh isn't going to be rendered, but the shadow will be.
Okay.
And that just gets more into the I go into it a little bit in the visibility culling and occlusion culling documentation with actors bounds.
Okay.
There's a bounding box and there's a bounding sphere, and you know, and what we kind of use those for. So the bounding box around the object is what we typically use for like ViewFrustum and occlusion culling, because it does have like a tighter fit to the mesh itself, so you get more accurate results. Like and that's what my next little scene was going to show, is like some of those issues I see come up often, like with people saying that meshes pop in,
Right.
or you know, and how you can kind of resolve some of those.
Cool. I think some of these are best
Just
at the
tackle
end.
it.
Yeah.
Okay. Not a problem. Okay, so this last one here, people have brought it up very often, and I just want to show you the effect first, and then I'll kind of explain what's going on. But as we move, you can kind of see off in the distance, like I've got a bunch of little meshes back here, little wall pieces, and this is a statically baked scene, by the way. That's why you get all that, the artifacts on the walls in the back. But as I move, you can see on the edge, you're getting that little white pop because I've got a very bright background and everything's just kind of coming in a frame later. So with dynamic occlusion queries handled by the GPU, what's happening is this entire scene within the ViewFrustum in my camera area is, like, we need to test all these objects, and we need a good way to do that. So we send those as occlusion queries to the GPU, and what it does is it reads that information, tests whether it's visible, and then a frame later is read back by the scene to know whether it's visible. So as I move too fast, I get some of that popping. Now, this can also depend on how large of a occluder you have in front of you. Like I've got this really big wall in front of me. Like if I'm further back, I'm not going to necessarily see it as much, but as I'm closer, I'll probably see a little bit more, just because I've got this really large occluder and there's all these objects that are behind it that have to just pop into frame. So let me first, did I have that as a thing? I'm sorry. I've got some hidden slides off screen that's like I wasn't sure if it was a note or if I had another slide that was going to be whatever. So one of the ways that you can resolve this, and actually you can do it by actually using, we have another occlusion method which I'll go into in a second, but I want to kind of stress the way you develop your scene first. And you know, for instance, like I probably wouldn't develop my scene to have like a bunch of walls like this unless it was absolutely necessary. Like this is just absurd to have this many like small little pieces put together to make up a single wall. If one object would make more sense, because you're you're one, reducing the draw calls, the number of objects that you have to test, and all these other things in the scene that you don't necessarily, that can be resolved by just having like a single mesh or a couple of meshes rather than all these like 60 of them that I've got lined up here. Another option, and I recommend using this one very sparingly. I'm almost don't even want to tell you guys. It's like a secret.
Whisper it. Nobody's there.
Oh,
It's
bound scale.
Oh, shh.
Oh yeah, yeah.
That's too loud. Yeah, that's-
Okay. So there's, we have an actor's bound scale. So, and what this is it's a bounding object around the actor. And let me just enable this. So I think it's under advanced, and then we go up here, show advanced. Carefully put my mouse up here, and then check bounds. And what I get is you know what's the easier way to do this? I can just open the static mesh editor. And then there's an option up here where I can click
Bounds. Yep.
bounds. There we go. And you probably don't see it as well on this one, but just because it's a box. So there's two things that come into play here. We have a bounding sphere around the object, and then we have this little blue outline that you can barely see that is the bounding box. And the bounding box is what we're using for that visibility testing. Now, you can do this on a per actor level. So I can either do it here in the static mesh editor. I've got more details in the actual doc if you're curious about this. I'm just going to show it here, or I'm sorry, let me go back to the scene. I'll just show it here, and then I'll let you kind of play around with the static mesh editor if you want to mess with it there, because you have more controls there. This one just does a uniform scale of it. But say for instance, like these little wall pieces back here, and it's like they're barely popping in. You can actually increase the bound scale on those. So if I did like 1.25, you can see that that's now increased. But what you're doing there is you're telling, okay, this is the area that I want to test, and you're telling something to be rendered longer than it probably should. So it's like if it were to be hidden behind a wall, the occlusion testing is going to check that bounds, not the actual mesh. So there's potential, like if I were to make it smaller or make it larger, is for it to like if I make it larger, it's going to be shown sooner because of the bounds that I can't see in every scene.
So is that done to like help it load ahead of time? In the event? Yeah.
Yeah, so it's like, yeah, you could totally do it for that. But again, it's just depending on the complexity of your scene, the number of meshes you have, whether you choose to do it in the static mesh editor and whatnot. There are reasons you would probably want to. I just suggest using it very, very sparingly. And be cautious and mindful of it, because it's one of those things you can kind of set it and forget it. And just go, oh crap, I have all this stuff, going on. Why are things being rendered that I don't want to? And for instance, like if you were to use like the freeze rendering, and something's there, it's like again the bound scale is hidden behind some menu, so unless you know what you're looking at,
Right.
you just go, oh well, it's being rendered, but it should be occluded by something. So, and I do recommend too not to use like whole numbers, like only increase it as you need it. So it's like, it's like if you're at 1 for your base, like don't go to 2. Again, there's instances where you probably do that, but it's like overall I would just use it sparingly.
Right.
All right, I've preached enough on that one. Okay, so another thing here before I kind of show you another hidden occlusion method, or not so hidden one that's in our docs, is again we have this popping stuff that's going on. Let me disable bounds. It's going to drive me mad. Okay. So we have this popping thing, and it's like I bring it up again just because like people have brought it up, like because like if you have something very bright behind the object that's popping in, it's probably going to be a little bit more noticeable. But some tricks that we can use, because I've seen people do it with caves and ask questions there, and they're just like, oh, okay, I didn't know about this. But what you can do is if you have, you can make like a single piece of geometry. It's like again, depending on your design, like some people maybe are doing like some procedural stuff, and it's like you have to use these smaller pieces that way. It's like you're kind of like procedurally designing something. But like Fortnite, for example, we do a lot of procedural stuff there, right? So, so with this, it's like if you put like an occluder mesh just kind of behind it, and I call it occluder mesh, but it's just really just a mesh that's darker. And fit it out to the geometry you want, just again, just depending on what you got. I can now really kind of move that fast range, and it's not, you're not noticing the pop. It's still happening, but it's barely noticeable at this point in this particular scene that I've got. And that would be an instance where I would actually say is like if you had like a small thing behind your geometry, so that way it kind of hides the pop a little bit more, but you're always wanting it rendered. You could probably increase the bounce scale on something like that to keep it rendered longer, and that's probably a good justification for using the bounce scale. So this last method, let me get rid of that wall mesh. This is a method that we use that uses a more conservative approach to occlusion queries, meaning that fewer meshes are going to be checked. It's a console variable that you can toggle on. It's r.hcb occlusion. And I've got a short blurb about it in the documentation, but not anything in detail because we don't actually use it here at Epic. We actually try and keep our performance within everything and just kind of use our standard ones that we are using more often. But it's not an experimental feature or anything. It's not. It has been production tested by other companies and things. So, but when we enable this, what we're getting is we're telling the GPU to use. It's kind of like bound scale for your scene, and what it does is it's testing fewer meshes. So while we can still get some of that pop, you'll notice I'm moving faster this time, but it's fewer meshes that are popping in.
Right.
Because we're being more conservative about not checking every single one as often. So, and then. Yeah, and then I think that was it for that. And then I was just going to do a little bit of a recap on what we've kind of covered. And then we can kind of go in some questions, maybe, if people want to do that.
They do have questions.
Okay. I think I've got an point. I got to go. No, okay. So really in this stream, what we covered was just ViewFrustum and hardware occlusion queries. And then, here, let me just minimize the editor because it's distracting me over here. So we focused on these just because these are the default methods that we do have and are automatically there, trying to save your scene's life and give it some breathing room.
Right.
And then the other option that I touched on a little bit that I would recommend, but I didn't really demonstrate today, is the distance culling one. That one's easy enough to set up. I've got a doc on that one. It's going over coldest volumes, some suggestive values that really work well for like a larger scene. And those volumes too can be nested inside of volumes. So you can do, like for people doing like these really open worlds, you can do something just like around your little procedural house or whatever and cull some things in there if you wanted, or just set some big values for larger stuff. For a really good trick too for like doing these open worlds is that they have these really large view distances. We want to use large occluders. So for instance, like if you had some hills or some mountains, I'm going to use Fortnite as an example because I played the crap out of it. You have these really awesome like viewscapes that you can have, but you notice that we've got like all these occluders as well. As like we got these really big mountains and rolling hills, so you're not always seeing it. I actually read this really interesting article on like just going to use it because like I thought it was awesome. But Walt Disneyland, like when he was setting that up, he made the world feel like you were in like different sections by curtailing how things are viewed. Right. So you never see other parts of the park except for the new Galaxy, the Guardians of the Galaxy thing, which towers. But
well, they do a lot of different like little special effects. Like people don't realize this when you're walking.
Oh yeah,
down,
the sound stuff too.
Well, they do the sounds, but if you're walking down like Main Street in Disney World, the windows will get smaller.
Oh yeah.
As you're looking down it, or the bricks on the castle get larger and smaller. Yeah. To make the castle appear. But they do a lot of that where they'll like make things
that forced perspective
right,
stuff.
Exactly.
Right.
They do a lot of that changing.
Yeah. So we're parsable. I use these large occluders to kind of reduce the things that are behind, and it can help save you a little bit of performance there, and then using the coldest and stuff can help. So the reducing the noticeable popping we just went over, and dark areas, those tricks. like I think there's plenty of posts I think on the forums. Like if you just Google search, like where I've actually suggested like some stuff. I don't have readily available to show you, but I want to tease you.
It's there.
Make you use Google a little bit.
Or Bing.
Bing.
We don't.
All right.
Sure.
Yeah.
So some of the useful debugging commands that I went over in this, we had freeze rendering, which is like a really awesome one. It's really good for moving your camera around using the at the very bottom there for toggle debug camera. That's a really good one for again, doing some of those quick checks and hotkey toggles for it. And you can actually, when you're in, you can only use it when you're in Pi, but it allows you to at least see your game running and go around and start checking those things. Another one I didn't actually show, but visualize occluded primitives. Here, let me pull the editor back up real quick. This one can get very messy, but if you hide parts of your scene or you're just trying to debug part of it real quick, okay. So what I'm seeing here is I see that bounding box that's being used to occlude. And you'll notice there's my wall, and then there's some other ones behind it. That's the directional light, the skylight, and all those other objects I have in my world. But, and you can see how for a very large world, it can get very messy. But if you're just trying to debug like a small little section, it could probably be beneficial to hide some of your stuff and just use this as a view mode to kind of get an idea. Because like as I move again, I do have HDB. HDB occlusion. You can actually visualize that a little bit better. You can see how it's being more conservative and not caring about these ones right here that are right out of view. But let me disable that. It's almost like I'm unprepared for today. So as I disable HDB occlusion, you can see that those 3 or 4 meshes that were not culled are now being culled. So that again, it's a good way to kind of test that. So there's some additional freeze commands. Like if you search in the editor, you can find those for like freezing foliage. I have these all listed in the doc as well. But you can freeze GPU simulation particles, CPU particles. Those can be useful as well, so that way you don't have a bunch of stuff. Yeah. And that's pretty much all I had. So we can start with questions, I guess.
All right. You ready?
No.
There's a lot of them.
I'm never ready.
So some have been asking, is there a particular method that's best for use in virtual reality, or is it just applying all of them?
So for VR, I definitely say the round robin occlusion. I know I only briefly touched on it in the beginning, and it's only a short little snippet of the doc because there's not really a whole lot that needs to be explained, but it's all runtime toggleable. So if you have a scene where you want it to focus on that, and then just disable it, or you're just using it to test, I don't remember it offhand, but it's on the doc.
Okay.
But yeah, that's you're saving. You essentially we're querying each eye, and now we're alternating and only doing one. Mm-hmm. So it's like alternating between the eyes. But the problem there that you get is like some of your stuff in the periphery, because like this eye is going to not necessarily cull as much over here, because it's not seeing all of those things as clearly as this eye would. So you can probably notice some artifacts there, but it's not anything I've personally tested. But that was some of the notes I was originally giving. I think I put warnings just to be aware of. But heck, you're saving like half the performance. Like
that's kind of important.
You're saving a bunch by not querying the scene twice. So
especially in VR.
Try it out. It's runtime toggleable. You don't have to do anything special.
So they're I think this is more when you're doing the Horizon Zero Dawn viewing, but they were asking if there's a far clip plane setting in UE4, or was that more demonstrative than anything?
That was more demonstrative. Just for the thing. We use scene depth. I'm not sure there's a way to change that. I've never looked.
All right.
I know you can change the near clip plane for how things are closer to the camera, but I think we just rely on scene depth for everything.
Okay. So they're wondering if they're discussing that they use sublevels to load modular rooms, and is there a way to cheaply cull whole sublevels as opposed to like they said hiding or unloading a level on the server stops physics to work for other players.
There's a section of the this works for Coldest Volumes, and I'm calling it out because I need to get the time to do it. But Coldest Volumes has it can work with level streaming, but there's some gotchas to it that I've not added. So if they're using cold distance volumes at all, then there's potential they're running into some of the hiccups. Other than that, just I'm not, unless you're just like streaming in the levels and just hiding them. I'm not too sure. And it's like again, it's like if you're using cold distance volumes, which would be awesome. But again, they got some gotchas with level streaming that I've just not tested yet and actually written anything up.
Okay.
So.
Let's see. So is there a difference in performance when setting cold distance on like every mesh in your scene versus using a cold distance volume for all those meshes?
Well, it's all being sent to the GPU, or not GPU, the CPU. I'd say you probably just have more of a headache of a time.
Setting
Like for instance, I'll use Fortnite just because I notice it. But like for instance, like I love the planes. I know a lot of people, that's a contentious thing. I love the planes.
Right.
But it's like, as you're going in, it's like they're at a certain distance, and that's that's probably set up as a blueprint actor or whatever, and it's got some code properties and whatnot. But I imagine that the distance is set there.
Okay.
And then you're setting it on a blueprint, so any of the blueprints that you set up, I wouldn't go through willy-nilly just clicking every mesh in the scene and just go, okay, I'm just going to change all these, because then you just have like a nightmare trying to keep track of all that. I'd say your quickest bet would be using cold distance volumes and setting up some general values. And again, I have an outline of like some really good like basic values to capture a lot of objects, and then you can tweak and add other levels in between, or you can choose to go and override and edit those individual ones that maybe if there's just like a few that are just being a pain.
Right. Cast a wide net and then
yeah exactly. And with the cold distance volumes too, it's like you can use I know this is for a future stream, but for demo stuff, but you can use cold distance volumes inside of cold distance volumes, so it's like that nested ability is like, if it makes it easier for you to navigate it that way, I guess. But.
All right. So they're wondering as far as how our instance meshes process through occlusion or frustum culling. So do they cull individually, or is the entire actor treated as one?
I know with Blueprint, I didn't test this, so I'm just calling stuff off the top of my head. So take what I say with a grain of salt, because I can't remember exactly. There's hierarchical instances, and then there's, I think, just the regular instances. One of those does not cull individually. It would just treat the whole thing as like one actor. So for instance, like if I set up like a for loop and I made like a wall or something like that, it would keep every single one of them rendered. One of those, I think it was the hierarchical one, would actually do the individual instances.
Okay.
And the notes I had here, let's go back down this for a second. It was for the freeze rendering stuff. There's the foliage dot freeze. So if you're using like foliage meshes, what that's doing is that's looking at each cluster.
Oh, okay.
So it's not culling every single. I don't think it's culling every single one, but it's culling the ones in that cluster.
Gotcha.
So you may have some that are outside the ViewFrustum or whatever, but.
Okay.
Yeah.
Do you have any feel for what impact ray tracing may have on these methods? So they're saying, rays could bounce anywhere, but it could be different than when it's submitting those draw calls.
I have no idea on that one.
That's all right. It's a good question. But
yeah, I'm not entirely sure. It's like I know we just had ray tracing go into the dev rendering stuff. I've messed around with it just a little bit, but it's still like early days for that stuff. It's active development. I know Yuri's posted on there that it's active development. So I have no idea. I haven't even I've messed with like a very small scene.
To be determined.
To be determined. Yeah. I hope it's awesome though.
Yeah, that'd be.
I was like, I love the ray tracing stuff, man. It's like we do some awesome stuff, and those engineers working on it, man.
Yeah. Is there any plan to have post-culling draw call batching?
I don't know what that is.
The batching. They're saying right now the batching is done manually,
Okay.
and can be hard to balance with culling. So, is there any way to do?
Yeah, I'm not entirely sure on that.
If that was your question, jump in and clarify a little. They're actually wondering, where do you go in and set all of this in the editor?
Okay, so for these two these two that I covered, there's really not anything that you need to go and set. That's why I wanted to cover these as an introductory thing, just because they're I mean, they're already on. They've been working for you for a long time without you even knowing. And a lot of people...
Secret culling.
Yeah, secret culling. It's like, I mean, they've been working and doing their magic for you. So let me go back to one thing and show you real quick here in the editor that I chose. Well, didn't choose. I just forgot. So if I bring up stat unit, what you're seeing here is you see the frame time that we're spending, the game, the draw, and the GPU. Most times when you're GPU bound, here, let me actually open up the Soul Cave.
No.
And let me get rid of that. I told you, it gets messy back there.
There's a lot going on.
Let me look down a little bit. So as you can see here, so our frame is like looking at the highest one for all of these, and if we look at the GPU, what we got is 8.33 milliseconds being spent, and that's where we're bound right now. So the GPU is saying this, like, hey, I've got like all these things that I'm doing right here, and using cold distance volumes can help reduce that and actually bring it back down a little bit more manageable. So, but the game and the draw are going to be your CPU one that you're keeping a little eye on. So it just depends on where you're bound and what method you're using. But as far as like settings go, there's not really a lot of settings that you need to use. I would say just using the other cold distance and distance culling stuff would be like your other like first step to kind of shift some of that balance from the GPU over to the CPU. But again, we'll cover that in another stream and go in a little bit more detail because there is more setup and actual things that you need to do there.
Gotcha.
Which is why I chose not to do it on this one.
Right. The promised part 2.
The promised part 2 and possibly 3. We'll see.
Uh-oh. For the whole year.
Are there any significant or main differences between the forward renderer and the deferred renderer in terms of how culling works?
I've not tested. I'm not sure.
Secrets.
Secrets, yeah, to me too.
Okay. Do you often stack these culling methods, or do you?
Yeah. So I'm always using, or we're always using ViewFrustum. You don't disable that. Depending on your project. So let's look in the editor real quick here. So if I typed it right. So we have an option here for culling under the project settings, and there's occlusion culling. And what that does is you can disable occlusion culling altogether if you wanted. Like for projects that are going to lean heavily on, like if you were going to use Precomputed Visibility as your choice, that's a generated offline method. You wouldn't need dynamic occlusion because you're doing a pre-computed dynamic occlusion with Precomputed Visibility. I know I keep saying the same words over and over again. You probably compounds, but thus again why we do these introductory things. It's like because it's a lot of stuff that we give you options for, and we do give you that flexibility to kind of move between these different things. So it can really kind of open up the possibilities for you and something that fits maybe your project workflow. But these are some things that maybe have been around for a while too. They're not necessarily new, but we keep adding new ones too. So. But as higher end devices get for mobile, man, it's like some of these mobile devices do dynamic occlusion queries now. So.
All kinds of things.
Yeah.
So someone was asking, should culling be thought of as a replacement for LODs or as a complement? But it's like you need to use.
Yeah, it's
both.
a whole separate thing, man.
Yeah.
They work together, right?
They work together. You want to use like LEDs, like you're reducing the amount of geometry that's in the scene.
Right.
The actual like geometry for each mesh, but what we're doing here is we're removing the draw calls. We're not drawing those objects that we don't care about.
Right. So you may have, like you mentioned earlier, little rocks or something.
Yeah.
While you have a statue in the distance and you want that to be visible, nobody cares about the little rocks that are on the ground.
Right.
And once you get closer, then they start showing up. But
like if anyone remembers the kite demo we did for the grass, like the grass was always around the player.
Right.
But it just kind of faded in, and it was something that was within a play range, because like if you had that entire scene being drawn with that much overdraw, is like you're just killing yourself on the performance.
Right.
So you want to curtail that down.
Yeah. So use both of them to optimize.
Yeah, absolutely. Optimization is always like a really big topic because there's so many avenues and so many different things.
Right. Especially with all the different hardware and finding out that best like sweet spot.
And identifying where you're bound to is like your biggest thing. So it's like knowing whether you're GPU bound or CPU bound gives you an idea of where you need to start. So it's like if I'm GPU bound, like sometimes like when people have hit me up on the forums or Twitter And I tell them, just, hey, take a look at this site and enable these settings.
Right.
And they're like, wow, okay, I've already, gotten like 16 FPS back. I mean, FPS isn't like this end all be all of like that is the determining factor of my game running, but you've immediately seen this, like you're getting milliseconds
You're
back.
finding ways to gain some of that calculation.
Yeah, exactly.
Back, yeah.
How does the culling system affect, or does it, the blueprints and collisions of cold actors? I guess most of the time that's a taking place off scene and you're not seeing it.
I kind of touched on it a little bit earlier, like with the toggle debug camera. So even though they're not being rendered, we're still doing a hit test. So it's like when it froze the scene, if it wasn't rendered or whatever, it's there. It's the hit test. So I mean, something being off screen, it's like doesn't necessarily mean that it's going to affect
that it doesn't
system.
exist. Yeah.
Yeah, it's not like deleted from the scene. It's just not being drawn.
Okay. Well, I think we're at the end of our stream. We've made it. You made it, Tim.
Oh, yes.
Well, thank you so much for going over it. I think this is a good foundation, again, for diving into some of these deeper occlusion topics.
Yeah, and it's a really big topic, which again is why I've volunteered for at least at least 2 streams, maybe 3, depending on the content. But yeah, it's a really big thing, and it's something to kind of wrap your head around. Like once you kind of start clicking and the picture kind of makes sense, it's something where you can kind of, like, I know people like to think of optimization as an afterthought sometimes, but the earlier you start doing this, you can start seeing those gains, you can start focusing on other things of your development. So.
And then that way you're implementing these best practices all the way along instead of this long slog at the end.
And
trying to be like, how do I get down?
I'm always amazed too. It's like we have a lot of like newer, maybe they're hobbyist developers or students that are coming along, or people that have been developing for a long time just aren't aware, or haven't been aware of these different things. That's why I fought for so long to get this documentation out there too, and have it to be like cover all these methods. So.
Yeah, no, this is absolutely great. Thank you again. I've tossed our live stream survey in the chat, so let us know how we're doing and what kind of topics you'd like to see in the future. It's super helpful to us, and if you provide an email address, we'll enter you for a raffle, and we'll raffle away.
Sure.
You can get engine shirts. I'm not putting you in the raffle.
You can enter, you're just not going to win. We'll give us your feedback.
For the opportunity to win an Unreal Engine t-shirt. And always check for your local UE4 meetup groups. So at meetup.com/pro/Unreal Engine. There's lots of incredible devs all over the world. If there's not a group that's active around you, you can always start one, and maybe you can let us know what you're doing in UE4. You want to talk about the countdown?
Absolutely. So every week we start our live streams with a 5-minute counter, and we show speed development. So if you're interested in sharing your project, send us a 30 to 45-minute clip sped up to 5 minutes of, if you're working in blueprints or you're working in level editor, whatever it may be. Like this you see here, we started with this one. And send that over to community@unrealengine.com. Include a PNG of your logo as well as a short description of your game and any relevant information, and you may see it on the beginning of the stream. We have, I think, 8 or 9 of them now. So,
but we'd love to see even more.
We want to see more. And people who've submitted, please feel free to submit an update if you continue to work on your project. So I think they're just a really cool thing to see.
They're a lot of fun to watch.
Better than a microwave opener. So.
And yeah, we're always looking for cool community spotlights at the start of the stream. So share your pieces with us. Oftentimes we're in the forums, also on social frequently. So
yeah, make sure you're following us on all the places.
Let us know what you're doing and share your projects with us. And we will see you next week with a stream on networking.
All right.
So thank you again, and thanks to you all for stopping by.
Take care, guys.
Thanks.